Okay, guys. So this topic here, it eventually leads to a certain type of equation solving. So that's why it falls into this chapter, because it's a type of equation that we can solve. But it starts out with just multiplying binomials using either FOIL or box method, and that's what these first couple problems are. So FOIL stands for first, outer, inner, last, as you can read here. And if you are going to FOIL, you're going to multiply the first two terms, 5x times 3x, as shown here. Then the outer terms, 5x times 7, as shown there. Then the inner terms, negative 2 times 3x. And then the last terms, L. So FOIL, first, outer, inner, last. So that's one way to do it. So you'd multiply x times x, and that's x squared. And the outer terms, x times 4, that's 4x. Inner terms, 3 times x, that's 3x, and then outer terms means the 3 times 4, and that's 12. So you can use FOIL to multiply two binomials, first terms, outer terms, inner term, last terms. Combine like terms at the end, 4x plus 3x to get 7x. X squared and 12 will just come along to the right here. So you could use FOIL to multiply two binomials, or you could use box method, where if you're multiplying two binomials like this, you can make a 2 by 2 box, and one of the binomials goes on the side, like 3x plus 4, and then 5x minus 3 can go on top, and then you multiply. You end up multiplying the same things as if you were doing FOIL, but it is a different method. So 5x times 3x, 15x squared, 5x times 4, right? You're just lining up whatever terms line up in that box and multiplying. 5x times 4 is 20x. Here, 3x times negative 3 is minus 9x. Then negative 3 times 4 is minus 12. Your like terms, 20x and minus 9x, you can combine those. 15x squared, 20x minus 9x is 11x, and then the minus 12. So you can use a box to multiply, and if you do use a box, you'll still normally, or a lot of times, end up with like terms. Combine them, and so you could use FOIL or box method. So FOIL would be, again, first term, 7x times 4x would be 28x squared. Outer terms, 7x times minus 3 is minus 21x. Inner terms, 5 times 4x, that's 20x. And then 5 times negative 3, that's minus 15. Combine the like terms. Negative 21 plus 20, so that's a negative 1x. Bring down minus 15. That one's done. Again, same problem done using a box method. I could put, again, a 2 by 2 box. 7x plus 5 on one side, 4x minus 3 on the top, and then 7x times 4x is 28x squared. 5 times 4 is 20x. 7 times minus 3 is minus 21x. Negative 3 times 5 is negative 15. Combining your like terms, 20x minus 21x leaves me with negative 1x still. 28x squared comes along for the right, and minus 15 comes along for the right. So again, you can multiply two binomials using either FOIL or box method, and you still get the same answer. So that's multiplying two binomials. Now, the opposite of multiplying two binomials would be like factoring. So here's what I do. First of all, you gotta kind of understand that you have these numbers when you have a trinomial square. Numbers, really we could put an a right here if we wanted to, so we can have a, b, and c. So if I relate ax squared plus bx plus c to this, a is 1, b, or should I say a is the coefficient of the squared term, the quadratic term. Squared term and quadratic term are the same thing. B is the coefficient of the linear term. The linear term is the one that just has x, not x squared. Basically x to the first power. So again, you have your quadratic term, a, right, x squared. A is the coefficient. You have your linear term. The coefficient is aka b, and then your constant is c. So we don't really need a, b, and c that much yet, but just to kind of get that thought process going, a would be 1 because it's 1x squared, b would be 6 because it's 6x, and c would be 8 because the constant is 8. And that would be, again, referring to a, b, and c in a trinomial square. So let's see here. So this first type of factoring is when it's a 1x squared. When a equals 1, all you need is this. All you need is two numbers that you can multiply to get 8, such as 1 and 8 or 2 and 4. Negative 1 times negative 8 would also be 8. Negative 2 times negative 4 would be 8, but here's the reason I don't need them. Because I actually need to pick the two numbers that not only multiply to give me 8, but add up to 6. Since they need to add up to 6, negative numbers wouldn't make sense here. If I made a complete list of all the integers I can multiply to get 8, this would be it. But again, I need the pair that adds up to b, that adds up to 6. So this is the pair I need, 2 and 4, because 2 times 4 is 8, and 2 plus 4 is 6. So again, I need two numbers that I can multiply to get c, but that add up to b. And once you have those two numbers, you can write it like this is showing here, parentheses x and parentheses x. And again, you guys might remember this from a different class. So once you have your general setup here, use the two numbers that are the correct numbers, the ones that have a product of c but a sum of b, and that's it. So this one's actually done. Same thing here. You could just use mental math, like for example, two numbers I can multiply to get negative 35 that add up to 2. 7 times negative 5, right? So you could just think of them sometimes. 7 times negative 5 is negative 35, but 7 plus negative 5 is positive 2. So anyhow, you can make a list if you wanted to. Negative 1 times 35, negative 5 times 7. You can switch the signs, positive 1 times negative 35, or positive 5 times negative 7. Here's why the last two pairs don't really make sense. You need the pair of numbers that adds up to a positive 2. If you need to add up to a positive number, and again, I do need one positive and one negative number because I need two numbers that multiply to give me negative 35. So again, if the numbers need to add up to a positive 2, these two pairs, this pair and this pair, don't make sense, because if I add this, I get a negative number, and if I add this, I also get a negative number, but I need a positive 2, so that's why I probably wouldn't even use those, wouldn't even write those two down. Anyhow, the correct pair is here, okay? Because negative 5 times 7 is negative 35, and negative 5 plus 7 is positive 2. Once I have that correct pair, here's my format. Parentheses x, put a minus 5 in one and a positive 7 in the other, and you have factored the trinomial. So factoring trinomials is the hardest part about the thinking. Is you have to think of two numbers that have a specific product and a specific sum. So moving right along, in this one I would need, again, the reason these ones are a little easier is because it's 1x squared. 1x squared. As soon as the x squared is not a 1x squared, like if it's a 3x squared or an 8y squared, that is going to make the problem a little more tricky. But if it is just a 1x squared, I mean, all I really need is this, and maybe you can use mental math if you like. You need two numbers you can multiply to get 6 that add up to negative 5. So maybe you can just think of that. Maybe you can just think and be like, well, negative 2 and negative 3 are the numbers, because negative 2 times negative 3 is positive 6, and negative 2 plus negative 3 is negative 5. Again, that works because it's a 1x squared. If it wasn't a 1x squared, it wouldn't be that easy. However, maybe you would just want to make a list of all the factors of 6. 1 times 6, 2 times 3, negative 1 times negative 6, negative 2 times negative 3. So if I know all the numbers, the pairs of numbers I can multiply to get 6, I need the pair that actually adds up to negative 5. So again, numbers that multiply to give you c and add to give you b. So again, you hopefully can see why minus 2 and minus 3 are the correct pair. On this one, I need numbers I can multiply to get negative 10, but they need to add up to negative 3. So negative 1 times 10, negative 2 times 5. You can switch the signs. 1 times negative 10, or 2 times negative 5. So I need the pair that adds up to negative 3, right? I know they all multiply to get negative 10, because that's the list I made, numbers I can multiply to get negative 10. But I need to pick the pair that adds up to negative 3, so 2 and negative 5. Once I have that, I can just use my x parentheses twice. That's my format. In one of them goes a plus 2, and the other one goes a minus 5. By the way, it doesn't matter what order you put them in. You can put plus 2 here or minus 5. And same thing, whatever I put here, well, of course, the other one goes there, so... But it doesn't matter which one goes first. X minus 5 times x plus 2 would be the same as x plus 2 times x minus 5. And now for the ones that don't have a 1x squared. If they don't have a 1x squared, here's what I do. First, I multiply a times c. So remember, a is the coefficient of the squared term, the quadratic term. B is the coefficient of the linear term, the x. Dang it. So it's b is negative 20. Sorry, that's a little sloppy. B is negative 20. C is the constant, so C is 28. So again, well, first of all, look for a common factor. If you look at these steps here, by the way, there's a bunch of steps. I decided that I like these steps better. These are definitely usable, but I decided I like these better. They just seem just a little less complicated. So in either case, it's a little heavy on the procedure, so do your best to work through it. So if I know what A, B, and C are, and normally I wouldn't have identified A, B, and C until I factored out a common factor, but 3, 20, and 28 don't have any common factors, so there's no common factors. The next step would be multiply A times C, and again, that would be in this problem 3 times 28, so that's 84. Now I'm going to list all the numbers I could multiply to get 84. Oh, and by the way, they need to add up to negative 20. So since they need to add up to negative 20, I'm actually just going to make both negative. Both positive wouldn't make sense since it needs to add up to a negative 20. Negative 2 times negative 42, negative 3 times 28, negative 28, negative 4 times negative 21, negative 6 times 6 is times negative 14, yes, okay, negative 7 times negative 12, and I believe that is my entire list. This is all the numbers I can multiply to get positive 84, and the reason I'm not using any positive numbers in my list is because I need numbers that add up to negative 20, so the only way I can get a positive 84 when I multiply two numbers, but then add those same two numbers and get a negative 20 would be using two negative numbers. So the pair that adds up to negative 20 is negative 6 and negative 14. This one is different. In this one, I'm not going to write any binomials. I'm going to rewrite the original equation. Sorry, it's not even an equation, but I'm going to rewrite the original expression. Instead of a minus 20x, I'm going to replace it with minus 6x and minus 14x. So minus 6x, minus 14x. So isn't minus 6x minus 14x the same as minus 20x? So substituting negative 6x and negative 14x in for negative 20x is okay because it still equals negative 20x total. Next thing you want to do is group the first two terms with parentheses and group the second two terms with parentheses and put a plus sign between them, because if you don't put a plus sign, you would basically be saying you're multiplying them, so put the plus sign. And then you want to factor each group. You want to factor the first group, 3x squared minus 6x. And so this you can factor out of 3x, common factor. You'll be left with x minus 2. Plus, anytime the first term is negative, you want to factor out a negative number. So I do want to factor out a negative. In this case, a negative 14. I can divide or factor out a 14. And again, if the first term's negative, make the number that you factor